I solved Alexa David's problem, which was problem 3-30, in which we were asked to find the temperature at the top of a transparent film and then the temperature of the air surrounding the film and solid plate complex. To do this, we had to know the thickness of both the film and the solid plate. We had to know the temperature at the bottom of the solid plate. We had to know the heat conductivity of the film, the H for the air, and then the heat conductivity for the solid plate. And we had to assume steady state, that there was 1D heat flow, and that the K and H's were constant. To do this, I decided to sum together the individual heat resistances for the two different types of conduction that are occurring and the convection term. And when I did this, I obtained the following R total. And I used R total to find the total amount of heat transfer. So that was just the total difference in the temperature divided by the total resistance, as shown here. And then I decided to set the total amount of heat transfer equal to the convection, and as well as the convection term equal to the conduction term. And when doing this, I had two equations with only two unknowns, which were T1 and T of the fluid. And after that, I plugged these two equations into Excel to obtain the following temperatures, which were that T1 equals 104 degrees Celsius and T infinity equals 84.3 degrees Celsius. Alexa David, however, decided to just simply set the conduction and convection terms equal to each other. And when doing so, she obtained a different temperature values than I did, which were a T at the surface of 103.23 degrees Celsius and 126.96 degrees Celsius. And while these two values were different, we felt that each of our strategies should be valid, so it was likely that it was a small calculation error that occurred either in mine or hers. So we decided we would present both and sort of see which one was right.